Ever wondered what goes on under the hood when you enter a URL into your browser, hit enter to load the page, and you get those few seconds of delay, and right after, a web page shows up? Or when you issue an API request from your application, your terminal, or even an HTTP client like Postman, and after a few moments of waiting, you get back a bunch of results. Well, within that period of waiting for the result of your request, you are actually communicating with the server. And what you get back is what the server interprets your request to be all about. Within that period, your browser or HTTP application, let's call them the client, is communicating with the server speaking a special language. This language is the language understood by all web servers, and the client needs to speak this language in order to communicate with a web server. This language is known as HTTP. HTTP is a short form for the term Hypertext Transfer Protocol. If this sounds like a fancy word, don't worry. We are about to break it down into clear bits. The first two letters of the acronym, H and T, stand for hypertext. The form of text transferred across the web is what is most often referred to as hypertext. It is a general term for text displayed on a computer screen or any electronic device. This also indicates that HTTP is a text-based protocol, but more on that later. The next letter in the acronym is another T, which stands for transfer. This indicates that HTTP is used for transferring hypertext from one location to another on the web. The transfer capabilities of HTTP is a superset of TCP, which is actually responsible for the transfer operation. And lastly, we have the final letter in the acronym, the P. P in HTTP stands for protocol. A protocol, simply put, is a set of rules used by two entities in order to communicate with one another. Now that we have broken down the individual parts of the HTTP acronym, let's try and define based on what we now know. We can say HTTP is a protocol used to transfer hypertext between entities on the web. This is why it is the communication protocol adopted by web servers and clients to communicate with one another. So, when you load up a website like Instagram.com on your browser acts as a web client and uses HTTP to talk to the web server at Instagram.com. So what really happens when web clients like browsers or applications are communicating with, let's say, a website like Amazon or an API like the Twilio API? What are they really talking about? You see, anytime there is a communication between a web client and a web server, the client is simply asking for stuff. Yup, this might sound too simple to be true, but trust me, that is all that is happening. You see, a server houses a bunch of resources. These resources can be web pages, images, videos, PDFs, information from a database, or software programs like a PHP or Node.js script that generates some form of content. Even a live feed from a camera can be sent as a resource. Remember Zoom calls? This is why the server is also referred to as the host, because it hosts resources. Also, why do you think it is called the server? This is because it serves resources to a client. Each server resource has a specific label attached to it in order for the client to be able to read or process it. This label is known as the MIME type. MIME, M-I-M-E, stands for Multipurpose Internet Mail Extensions. It is a standard that was initially developed to solve problems encountered in moving messages between different electronic mail systems. However, it worked so well for emails that the entire web architecture decided to adopt it. Let's say a server needs to send a web page to a client. To this web page resource, the server will then attach a standard MIME type of text/HTML. What this tells the client is that this resource contains text and it is for the HTML format. This way, if the client has capabilities to display HTML pages, something browsers can do in their sleep, the client can then render the HTML page. If the client does not have such capabilities, such as when you make a request from your Python or PHP script, the resource will be returned as just text. There are also resources like images with MIME types of image/PNG, image/JPEG, image/GIF, and so on, depending on the image type, that cannot be returned as text but in a binary format. Now you might ask, isn't HTTP a text-based protocol? And you will be right. But here's the thing. The communication is in text. However, the resources sent back and forth can be binary. What this means is that while the HTTP communication between the client and the server will always be done in text, they can share binary resources. So, how does this communication take place between a web client and a web server? To begin communicating with a server using HTTP, a client needs to first decide on and know a few things. First, the client needs to know where the resource it wants to request is located. This starts with where the server is located. This can be an IP address or domain name of the server. For a site like Instagram, that will be 179.60.195.174 or simply instagram.com. Next, the client needs to know where the resource it wants is located on the server. You see, the domain name or IP, or server address as some might choose to call it, is like knowing the address of an apartment building. However, for you to see the person you actually came to visit, you still need their apartment number and you need to know their name. So, let's say I want to get my profile picture from Instagram. And let's assume that Instagram stores all profile pictures in an images folder with the name of each user. Then, the path to my profile picture, which is the resource the client is requesting, will be images/fk, which is my name, .png. So, to fully access my profile picture, we need the domain name and the location of the resource. If we join that together, we get instagram.com/images/fk.png. One final thing. To request this resource using HTTP, there is a special HTTP signature that is used. This is the http://signature, which is to be added to the front of the location of this resource. When we add that, we will have this: http://instagram.com/images/fk.png. What we have just constructed is what is known in the web world as a URL. Hello guys, this is FK, and honestly I am tired of all the debates and arguments I'm seeing on Twitter and Reddit about which programming language is better or which framework is better. While many developers are still lacking in the understanding of how programming languages work, how databases work, how web servers work, and how even software systems work. Lack of understanding of these main fundamentals has been the reason for things like imposter syndrome, not knowing whether you're programming the right way, or even struggling to try to be a senior developer. So, I have taken it upon myself to teach these core fundamental topics. These topics never change, and they form the bedrock of any proficient developer, DevOps, cloud, or blockchain engineer. So, if you want to get free materials and videos sent to you every week, use the link below to join our fundamentals community. I can't wait to share exciting software fundamental lectures with you as we all strive to become better software engineers.
URL is an acronym for Uniform Resource Locator, and that makes a lot of sense. It is a uniform way for locating resources on a web server, of course using the HTTP protocol. If you would like to learn more about HTTP URLs, their structure, and how they are processed on the server, I have an entire video dedicated to that on this channel. If the video is not currently out while you are watching this, be very sure it will be out the next week. So, subscribe and turn your notification on to get notified immediately the video drops. Now back to HTTP. Now that the client knows where the resource is, the next thing it needs to know is what it wants to do with the resource. Is it trying to request the resource itself, like an image or a video, or does the client want to send a command to the resource, for example, to add a new record to a database? This will determine the method with which the client communicates with the server. HTTP provides a set of standard methods that a client uses to communicate with a server. Let's take a look at the most common ones. We have the GET method, which is used to fetch a resource from a server. The POST method, which is typically used to issue a command to a server to add a new resource. The PUT method, which is typically used to issue a command to a server to update an existing resource. And then we have the DELETE method, which, as you may have guessed, issues a command to the server to delete an existing resource. While these are the most common methods used in an HTTP communication, they aren't the only ones. We have other methods like add, patch, and others. If you want a deep dive into HTTP methods, I have another video dedicated to that. Knowing the location of the resource the client is interested in and what method of communication it wants to have with the server are the two most important and required elements in opening a communication channel with the server. With these two, the client then opens up a connection with the server and sends what is known as an HTTP message. You see, communication between a web client and a web server is two-way. The client sends a message and the server responds with another message. The server's message is a response to the request made by the client. This is why client messages are referred to as request messages, while server messages are referred to as response messages. You know what? Let's have some fun. Let's take a look at how HTTP messages look like, starting with a request message. Displayed on your screen is how a typical HTTP request message coming from a client looks like. Yeah, looks a little intimidating, doesn't it? Don't worry, before the end of this video, you will not only be able to read these HTTP messages, but you will also be able to take a crack at writing yours. So, let's break down this request message. Everything above the line is called the start line. For a request message, the start line tells the server what the client wants it to do. The start line starts with a request method, which in this case is a get. This indicates that we want to get the resource we will be pointing to on the server. Next on the start line is the location of our resource. This can be a complete URL like the one we constructed with the Instagram profile picture, or a relative path. More on URLs and paths in my URLs video. Here, we are requesting the contents of the text file message.txt. And finally, on the start line, we have the version of HTTP we want to use to communicate. HTTP as a protocol keeps evolving and has gone from version 0.9 to version 2 as at the time of recording this video. While most of the web still uses versions 1.0 and 1.1, most of the core functionalities stay standard and unchanged. So, there is no serious need to worry about versions except for edge cases. Just after the message line, we have what is known as HTTP headers. HTTP headers are a way for a client to communicate to the server extra information that the server might find useful. The server also does the same for the client. This is not part of the typical payload that a client might need to send to a server, but functions as metadata for the request. In this example, the client is telling the server what user agent it's using, which is a Firefox browser on a Windows machine. It also tells the server that it is capable of accepting text-based formats and supports responses in English and French. With this information, the server can be equipped to fashion the response more to the client's needs. This provides a great way for clients and servers to negotiate content. Now, don't get yourselves too confused on headers yet. If you need more information or just want to nerd out on HTTP headers, I have videos dedicated to the topic. A request message can also contain actual data to be sent to the server. For example, to add a new record on the server. This data is referred to as the payload, and to add it to the current structure, you can add an empty space after the headers, have another line, and everything that follows after this line is recognized by the server as the request body. The data in the request body can then be used by the server to perform the task it has been commanded to do. Now let's look at a response message. A response message also has a similar structure to a request message, with the only difference being the start line. While the start line of a request message tells the server what the client wants it to do, the start line of a response message tells the client what happened on the server. The start line of a response message consists of the HTTP version the server is using and a numeric character called a status code, followed by a reason phrase. Every response returns with a status code, which is a 3-digit number that simply tells the client if the request succeeded, failed, or if other actions are required. Clients and application developers can use this code to determine the next course of action. The reason phrase provides a human-readable explanation for the status code. While the client does not use them in taking decisions, they help users understand better what happened to the request. And as you may have guessed, of course I got you covered on status codes. An entire video has also been dedicated to learning about status codes in this HTTP fundamentals journey. They are quite fun to learn. There's literally one called I am a teapot. Now, just after the start line for the response message, you have the response headers, which mostly describe the response that was sent back. And after the header section is the response body, containing the requested resource or result of a command operation. For more information on HTTP messages, yeah, we have dedicated a video to that also. So, we have seen that web clients and web servers communicate using HTTP. We have also seen that this communication involves sending messages back and forth, a process which is professionally called an HTTP transaction. But what if this connection or communication pipeline breaks? What happens to our messages? Do we get a truncated message? Do we lose the entire response? What if all our request information does not get to the server? Well, as developers, DevOps, cloud engineers and software professionals, we don't have to worry about that. This is because HTTP uses TCP under the hood. Remember TCP, the guy I said is actually responsible for the transfer of HTTP information? Yeah. TCP, which is a short form for Transmission Control Protocol, is a standard network transfer protocol built for reliability. Any worries you may have about your HTTP messages getting to the server and back from the server, TCP already takes care of it, and even more. With this reliable transmission, developers and software engineers need not worry about HTTP communications being destroyed, duplicated, or distorted in transit. You can sleep well without worrying about the shortcomings and uncertainties of the internet. So, that is HTTP. And I hope you can now confidently say, I do understand HTTP. Yeah, a little brag won't hurt. Be sure to check our other HTTP videos to get more in-depth knowledge on all concepts we have touched here. Till then, go be the best you can be.